11:30, here we go. Good morning. Everybody just doesn't feel right when there's only two of you. Good morning, both of you?
Yeah, good morning.
All right. This is a wonderful quote, by the way. That as I'm thinking about it, this is exactly how complex numbers started out, right? The guy accepted, okay, I accept that I can't take the square root of a negative. But what if? Just for entertainment value, what would happen if we did anyways, right? He started entertaining the idea before accepting it. And it turns out, oh, hey, that's actually fairly useful. And now, eventually, we accept it. Like, this is how new things come about. Like, you got to try stuff before you believe it first. You don't know what'll happen. Anyways, today we're continuing with complex numbers, and we got into all the theory and the history of it yesterday. Today we're just going full hog, practice, practice, practice. Let's see what we can do with manipulating these guys. How different does it actually make our arithmetic? And for the most part, it's not too bad, honestly. When it comes to simplifying, keyword, if you're simplifying stuff with imaginary numbers, you can treat them more or less like a variable. Right? If I had shown you this in Algebra 1, you would not have thought anything unique about the letter I. You just thought, hey, we've done X, Y, Z, A, B, C, why not I? Right? And you'd say, hey, there's one I, there's 6 I's. All together, they make, combine the like terms, 7 I's, right? That's all there is to adding the I's together. That's honestly all there ever is to adding the I's together. Add and subtract, you're just combining like terms. They don't change anything in those terms. The interpretation of, right, we understand this is a number in a different direction, a new dimension, but as far as the arithmetic here, not a big deal. However, everything changed when the Fire Nation attacked. And when we start multiplying, stuff gets different, okay? I've got a thing out here, I've got stuff in parentheses separated by an add or subtract, so I am of course going to use distribution, and we multiply 4i times -2. Treat it just like a variable. -2 times 4 is -8. We still have times I. And now we have 4i times -8i, so -8 times 4, 32, and then I times I is I squared, right? But we're not quite done. This is the catch, right? The catch is anytime I ends up with a power other than 1. You've got further simplification to do. So everything else, treated exactly like a variable, just go on through, go simplify, follow all the same rules, except one more step. Double check, hey, does any of my i's have a power on it? If so, your I no longer stays plain old I. Because remember, we know I to the first power is, it's just I. But I squared is by definition -1. I cubed ends up as -1 times another I, so -I. And I to the fourth gets back to that same as -1 times -1, +1. Okay? Until that becomes automatic habit, I recommend at the beginning of every page that deals with complex numbers or imaginary numbers, you write that down. You take this little guy, like at the beginning of every, page, you're like, okay, new worksheet, what am I dealing with? Oh, complex numbers. Okay, quick, jot this down. I is this, I squared is -1. Okay, I've got my reference, right? You start with that. Anytime, you refer back to that. And then, of course, the pattern continues. As we saw, I to the 5th is going to be the same as I to the 1st, because we just loop back around the cycle. So let's apply that to down here. We have I squared. So this turns into -8I is untouched minus 32 times -1. And when you multiply by -1, instead of -32, it now becomes +32. So final answer, -8I plus 32. Okay? And so the more practice with that, the fewer times, fewer of these lines you will actually have to write out. Like I would probably never write this one out. Right? I would look at this and say, oh, I squared, that's just times a -1. Oh, I just need to change this sign. Write that down. Right? If I was in the groove of things, maybe I can spot that as I'm multiplying this and I'm writing it out. -32, I squared. No I, plus 32, done. Right? I could kind of work through it just on that first line, maybe. I'm like, fully admit, I'd have to be in the right zone to be thinking that far ahead, but it's doable, okay? You do whatever you're comfortable with, and then you just, stick a box when you're done. All right? Not too bad, and I was going to go over one more. I jumped the gun. I guess I kind of already explained the multiple powers thing here. I was going to use 24 as a good example, right? Here it is, even more than squared. 6i, all cubed. Okay, you can use your power of a product rule to say that's 6 cubed times I cubed. Anybody know what 6 cubed is? Anybody know what 5 cubed is? Oh, come on, folks.
Isn't it 6 cubed 216?
216, very good. Okay, start committing those cubes to memory. They'll make things go so much faster because they'll appear all over the place. Right? 5 squared, that's 25. Everybody knows that one, right? 4th graders know that one. Step it up. 5 cubed, 125. Have that locked away. Lots of people know that one. 7th graders know that one. Let's go. 6 cubed. It's like it's just one more, and yet nobody bothers to memorize this one. It's not as pretty. I don't know why. Right? You used to go 5 cubed, it's 125. It still ends in a 5. Look, this is 6 cubed. It ends in a 6. It's got the same pattern to it. It's wonderful. Anyways, 216. And then I cubed becomes -I. So we still have to, we don't need to write a multiplication symbol. 216I, and put the negative up front. All right? And I think that was all that I wanted to talk about. Right, the critical thinking questions here at the bottom, as titled, require some critical thinking through. I kind of mentioned how you can treat I the same as a variable, but there are some differences. That's what they're looking for. What is different versus using X versus I? What changes? All right. Any questions at this point? No? All right, then have at it.